Good morning, good afternoon, or good evening, depending on what part of the world you're in, and welcome to the Nautel webinar, The Complete Guide to Nautel's RF Toolkit, the radio coverage tool. I'm Chuck Kelly, and I'm delighted to be with you today. I'm the Regional Sales Manager for Nautel's Asia Pacific region, and my very, very special guest is an old friend, Mr. Roger Coudé, who's a retired electrical engineer and the developer of Radio Mobile, and lives near Montreal, Quebec. That's where he joins us from today. Hello, Roger.
Hello. Hi,
Nice,
everybody.
nice to have you with us. You and I have known each other for probably 20 years now. Something like that, yeah. So we're going to talk today about the RF toolkit. We're going to talk about how propagation analysis works and what are the limitations and what can the Nautel radio coverage tool do, where to find it, and then we're going to actually spend most of the webinar actually walking through the various steps that are necessary to run the RF toolkit in all of its functions. And then we'll have the opportunity to take your questions. Now, that you'll note as part of the application that you've got on your screen, the GoToWebinar application, there's a section called questions, and you can answer or you can ask questions in that box at any time throughout the webinar, and at the end of the webinar we will answer those questions to the best of our ability. Any that we can't get to in a reasonable time, we will answer offline by email. Remember that the completion of the Nautel webinar qualifies for a half SBE recertification credit identified under Category 1 of the recertification schedule for SBE certifications. So first and foremost, what is the RF toolkit? As the title infers, it's a set of tools designed to help both technical and non-technical people easily understand complex systems. The coverage tool allows users to analyze possible transmitter locations, tower heights, antenna gains, and transmitter power levels for coverage. It's a free what-if tool to help broadcasters understand the approximate coverage of a proposed station or change and to determine the likelihood that a point-to-point link will be reliable. As always, we have to talk a little bit about the legal stuff. The tool is intended to aid broadcasters in analyzing the approximate coverage. While it's based on well-proven Longley-Rice algorithms and publicly available SRTM data, it cannot be guaranteed, and Nautel cannot assume any liability for the results. Further, it's not meant to be a replacement for coverage studies or other work done by professional consulting engineers. Please, please, please consult with a qualified engineer before applying for your license or ordering your equipment. How does it work? It's all based on Longley-Rice. Longley-Rice is an algorithm that does coverage analysis, pretty well known, pretty well accepted around the industry. In fact, most of all the programs that are out there that do coverage analysis in the VHF and UHF bands are derived in some fashion from the Longley-Rice algorithm. If you are having trouble sleeping at night and would like to have a lot more information about this, that hyperlink right there will get you to a lot of the foundational material that describes Longley-Rice and how it works. And the databases that the radio coverage tool are based upon, we use a digitized terrain database which is available from NASA, which is called SRTM, which stands for Shuttle Radar Terrain Mapping. That's right. As the space shuttle was orbiting the Earth, a radar antenna pointed down to the Earth and determined the altitude of all the spots that it passed over. From 60 degrees north latitude to 60 degrees south latitude, the database has an accuracy of 1 arc second, which is roughly 30 meters. That means that every 30 meters in any direction, the SRTM data knows the altitude of that site above or below sea level. Above and below the 60 degrees north and 60 degrees south, the accuracy is reduced to 3 arc seconds. So that those areas that you see on the map on your screen that are green, which is where an awful lot of people don't live, are 3 arc seconds, which is an accuracy or a resolution of about 100 meters. And the database that has all this information is in the neighborhood of 465 gigabytes. So a lot of data. In addition to that, there's other databases that are utilized. We have ground cover information that helps the algorithm understand how this signal interacts with the ground. That data was last updated 5 years ago. Roger, I think you said that you got it from a university and then have since updated that. Is that right?
Yeah, the original land cover came from the University of Maryland, and it was 1 kilometer resolution. Then we got USGS for the United States and Geomatics Canada and also the European community. Now we have much more precise land cover.
That's great. And that is used by the model to determine, or by the algorithm to determine how the signal bounces off the ground and what height the ground may be. Is that right?
Yeah, that's a good question, because we have to make a choice, because we didn't want to alter to modify the Longley rise. The main reason for that is I personally use it in some studies that I had to prove that I was using a well-renowned algorithm. Okay, yes. And because of that, the way we use the land cover is to add additional loss to the already computed loss by the Longley rise program.
Okay, so it makes it a little bit more conservative.
It's as an example, if there is a tree, it will not be seen as a supplemental obstruction 8. Right. It will be seen as a loss of signal through the penetration.
I understand. Okay. And the other major database is the population data. This is how we're going to tell you how many people are living within a particular coverage contour. And that information comes from the United Nations. And it's updated as often as countries update that information to the United Nations. Is that probably pretty correct, Roger?
Fair enough.
Okay. All right. So we have two parts to the tool: the FM radio coverage prediction and the point-to-point link analysis, which is used for STLs or RPUs. So right now, what we're going to try to do is go live to the videotape and try to show you how to do this. So here's the Nautel website, the same website you would normally go to, www.nautel.com. And if we zoom down or scroll down just a little bit here, we can see the RF Toolkit. We'll click on that. And now here we've got to log in. So you go up to the upper right-hand corner. If you don't have a login, you can register for free in the Register tab, and you will get that information almost instantly. You'll have to put in your email and your name and all that stuff, and then it will send you an email to confirm and give you your login information. So I'm going to go ahead and log in now, and there's my login and password. And now we are logged in, and I can go to the RF Toolkit page, click on that, and I can go to the radio coverage tool. Now, the very first thing that we're going to want to do, this is the menu for the radio RF Toolkit, the radio coverage tool. Very first thing we've got to do is create a new transmitter site. Okay, so we're looking at the actual area around Montreal, Canada. And I see here that there's a hill, and Roger, you said that's a rather prominent hill in Montreal.
Yeah.
And I'm going to call this Montreal transmitter. So I'm going to move this around a little bit, and then put it on top of the hill as far as I can see, and then submit that.
Can you zoom in?
Up. I can do that. Go locate.
Yeah.
Yep, and zoom in a little bit more. Yep.
Yeah.
Okay. You think I should move it over to here?
Yeah, maybe in the middle of the...
Or over here on the right?
No, that's lower.
Okay, so let's just stay with this one for now. Okay, we'll hit submit. And we're going to call this Montreal transmitter. It's 331 meters above sea level. Now we're going to add that to my transmitter sites. Now we've got the information, we can go ahead and do a coverage plot. So let's go ahead and do a coverage plot here. And we'll use the site Montreal transmitter. Our frequency, let's say 99.1. And the antenna height above the ground. Antenna height is the center of the height above ground. So we're going to say 100 meters. That's the tower height to where the antenna is. And let's choose a 1 kilowatt antenna, or a 1 kilowatt transmitter. That's transmitter power output with a 4-bay antenna. Now, we have a number of pull downs that are choices here for various receive contours, but in this case, I'm going to choose the FM car receiver. That's a preset that we went ahead and configured based on the average of car radio receivers and the fact that the antenna on a car is only about a meter above ground.
Okay,
yeah, go ahead.
You should change the description to be more specific.
Okay.
On top.
Oh, yeah, that's right.
Yeah.
Okay.
Otherwise, you will have problem to find it.
Yep. And
Cool.
we'll do that, and so we'll do that. And I will say 4-bay. All right, and let's reduce the maximum range a little bit. That will make it easier for the system to process this quickly. And when I hit the submit button, tell me what the process is that the system is going through at this point, Roger.
So the first half of the job is to extract the elevation data. You see, it was quite fast because probably the map were already in memory. And the second half is the calculation itself. So it's only no computer time.
Okay. While it's doing that, let's shift over and go back and talk about a couple of things here. See if I can make this work. And hit F5. And so let's talk about the various presets that we have available on the transmit side. You can see that we have a number of power levels and gain bay combinations here. And what's really cool is, and this is really only for advanced users, at the very bottom, Roger and I put a custom field. And what that allows you to do is enter yourself the TPO under transmitter power in watts, the transmitter line loss in dB, and the antenna gain that is calculated for your particular type of antenna. If you don't use custom, if you use one of these presets up here, the program itself estimates the line loss by knowing the height of the antenna above the ground and the power level, and it knows the approximate gain of the antenna from the number of bays, and so it's close enough for government work, as they say. On the receive side, you have a similar set of choices, the FM receiver mono, stereo, and then a number of presets that are configured and by various parts of the world. Standards in the US tend to be 60 or 70 dBm or dB microvolts per meter. European standards, various television standards, but you can also click custom at the very bottom, and then you can set the receive antenna height, receive level contour 1, and receive level contour 2. So 54 and 60 is what we've chosen in this particular custom one. So that's that. Now let's go back and see if our model is done. Go back here, and yes, in fact, we have a map. Now, this map is useful and it's very interesting, but it is not as good as it gets. What we can do is we can add that to my coverage plots here. So we click Add to My Coverage Plots, and then we go to My Coverage Plots, and we pick up Montreal with the 4-bay and view that. Now, when we've done that, we can do a lot more. Oh, we've had a problem. We have a bug. So
no, it's strange because you have your key. Anyway.
Yep.
Do a refresh.
I can try that. It's refreshing now. We'll go to My Coverage Plots, and we'll come down to that again and see if it works. View. Now it's okay. All right, so there's something going on. We're in the process of changing around from Google Maps to OpenStreetMaps, but for now, this is what it looks like. So now we have all the information. We have the the two contours. The yellow contour is the 33.6 dBUV per meter, which is a weaker signal contour, and the green color is a stronger signal contour of 43.6 dB microvolts per meter. Now, what's interesting is not only can you see it graphically on this map, but you can also see the number of square kilometers that are covered. So 23,377 by the weaker signal, or 16,617 square kilometers for the stronger signal. And that's what you would expect. But in addition to that, we've also got the population covered in each one of those things. So you've got about 4.9 million people hearing the weaker signal or more, and 4.36 million people able to hear the much stronger signal. So that's very, very valuable. But wait, there's more. If I click down here, well, first let me do one more thing before I do that. What I would recommend doing in this situation is moving this over to the right a little bit and then clicking the description button. That kind of labels everything with all of the information that was created when we established that. So you've got the description, the frequency, the base name, the latitude, the longitude, the elevation, antenna height, base antenna gain, mobile antenna height, that's the receive antenna, transmitter power, and the line loss that was calculated on the transmitter side. So all of that is kind of labeling this. Now, if what you'll do is you'll hit the print screen button. And if you hit the print screen button, then you can go take the signal, you can take the clipboard and go into something that you use for graphics editing. And I'll show you what I've just done. And we'll go to the clipboard here. And now I've got that there, and I can take and copy that like this, and do that. And now I've got a JPEG, for instance, that I can just copy and paste into any kind of document. So that's very valuable. But let's go back to our original application here. And we will click here on Advanced, Files of Montreal, 1 kilowatt, etc. It's downloaded a zip file. Now what we're going to do is Show in Folder. And I'm going to click it so you can see this, Downloads. Now I'm going to hit F2 here and change the suffix to KMZ. Okay? So that's going to make it much easier to work with. Now I'm going to double click that, and my system has Google Earth installed on it. And when I have installed Google Earth, now you're able to see all of the information that we just had shown right in Google Earth. And one of the things that I can do is I can actually right click and hit Properties here. And
you have to expand first.
I'm sorry?
You have to expand first.
Oh, yes, of course. That's right. Oh, thank you. And now I can do the properties, and now I can change the opaqueness level of the coverage map as it's laid over the Google Maps, and I can see that. So not to put too strong of a point on it, but there's an awful lot that you can do with this information, that you can see where the coverage is, and you can see where the limitations are. So that's how Google Maps, the program Google Maps, fits into the equation. So now let's go back here, and you can create multiples of these. Let me see here. So if we go back to the main menu, I can create multiples of these of coverage plots with the various assumptions written in the description in the file name. And then I can have multiple coverage plots and put several of them on the screen at the same time to see how a network might be created. And that's very, very valuable. So you have the capability of seeing multiple coverage plots at the same time. All right, let's go back for a second and talk a little bit about point-to-point links and what that does, or maybe I'll just move on that way. Let's just go ahead and do a point-to-point link. Now, for any point-to-point link, I have to have two transmitter sites. So let's go back to this map of Montreal and zoom in down here in downtown, and let's zoom up a place that we're going to put a studio. Let's put the studio at IKEA. All right, so the IKEA is going to be, we're placing the cursor there, and then we'll put it over here on top of the IKEA. And now I have transmitter site number 2, and I'm going to say Montreal Studio. And that's only 34.3 meters of elevation. And we'll add that to my transmitter sites. Now I've got 2 transmitter sites, and I can actually do a point-to-point link. So I'm going to say we're originating from the studio, and we're going to the transmitter site. The antenna height at the studio is going to be, say, 20 meters, and the antenna height at the transmitter is going to be about 40 meters, and we're going to call this Montreal TX, or Studio to TX. Now the frequency of our STL, let's pick 950 megahertz, and the watt, it's only 10 watts. In the line losses calculated there, let's say the antenna gain is 20 dB and the receive antenna gain is 20 dB. So these are dishes that we're putting up here, and the line loss on the receiver is 0.66 dB, and the threshold is 10 microvolts, and the required reliability is 70%. Now, Roger, you've derived that required, the reliability of the link is going to be far more than 70%. Obviously, for an STL, it needs to be 5 nines or better.
Okay, the reason for that 70% is to get a realistic value of a measured signal.
Okay.
So for sure, you want to have more than, this is the minimum signal you ask for.
Right.
You will need mountain on top of that.
Okay. So the fade margin is what gives you the 5 nines. Right?
Yeah.
Okay. So now we're going to go ahead and click submit. And this one happens much faster. Even though we can see there's multiple people. Now it didn't work because there's another hill in the way. Ha ha! There's another hill in the way. So can we click here? No, we can't. All right, so we'll modify the link. We'll have to return to the main menu because we've got to go to transmitter sites. That's not going to work as it is unless we put up a really tall tower. Let's try that. Go ahead.
Yeah, you will. You will need a 1,000 meter antenna. So
that's a little crazy. All right, so let's go back and look at point-to-point link, my point-to-point links, and we'll come down here. Where did it go? Oh, I never saved it. Okay.
No, you never saved it. So,
yep, that's right. So we got to go back here and do a new new point-to-point link, and we're going to go from Montreal Studio, but we got to move Montreal Studio, don't we?
Yeah.
Yeah, we really need to move Montreal Studio. So let's do that. Let's change and change. Where do you think's a good spot, Roger? That's not going to get that problem. Maybe.
As an example, you can zoom in where Montreal is written. Okay, go down, and select a side that on the side of the mountain on the east.
Okay, all right. So we'll do that. Place the cursor here, and right there.
If you ever lose a cursor, you just place it at the center. There's a button for that.
Okay. Place the center at the cursor, like that. That's what you're suggesting?
No. If you, as an example, if you were in Europe and you moved to USA and you lost your cursor,
sure, that'll put the cursor
at the center of the existing map, and that's it.
Okay, so we're going to call this Montreal Studio 2, and it's much higher, 211 meters. So let's do that. Now we'll create a new point-to-point link from Montreal Studio 2 to and that'll be 20 meters, and Montreal transmitter 20 meters, and and 950 megahertz, 10 watts, line loss, 20 dB gain, 20 dB gain, 0.66 in terms of receive line loss, and they keep the thresholds the same, and go. Okay, why is it not doing that?
Without. Press modify this link.
Okay.
And without, well, because we, yeah. Because we use the same site name, or just remove the asterisk in the name, the description.
Okay.
Try again, submit again.
Okay. There we go. And now it works.
Okay.
Now it works. So what we can see here, yep, the left side is the studio side, the right side is the transmitter. It shows the relative ground elevation and the antenna heights, the azimuth, the tilt for both of them. Then there's a calculation of all the losses. So we have a total path loss of 129 dB, but we have transmitter power and the receive sensitivity added up to far more than that. So we end up with a fade margin, a total fade margin of almost 36 dB, which should be pretty reliable.
Mm-hmm.
And you look down here and we can actually see a map of what we decided to do. So that's how that works. And now let's go back and look at the PowerPoint. And so one of the things that you could see on that point-to-point link is the ground cover, the land cover. And you can see the different colors here, like this blue here, that is urban and built up, low altitude. And this red is urban and built up, high altitude. And there's mixed forest in here, and over here there's evergreen forests. So it shows you what the calculations are. Now, one thing that I think is important to mention is the program can't possibly know that somebody just built an 80-story building in the middle of your path. So you need to verify the calculations that are done here and verify that you've got line of sight. Would that be accurate, Roger?
Yeah.
Yep. So there's no possible way for the system to know.
But at least you know the path. You look at the map we had before, and you know where you have to look.
That's right. And if you know there's a building along this path, then you can calculate that out and look at it on the path. By the way, the 3 white lines above and below the actual path are Fresnel zones. And if those are touching the ground in any fashion, or any part of it, like here, if it actually touched that, there could be refraction or reflection that would end up either adding or subtracting from the signal at the receive side. Right?
It depends on the type of modulation you're using.
Sure. That's right.
Modern wireless link, they probably use chips that can be, let's say, synchronized, and they will not be sensitive to the reflection.
Right.
But if you use a standard analog transmission, then you may be very sensitive to destructive reflection.
That's right. That's right. Because it kind of creates a comb filter effect.
Yeah.
Yep. Okay. Here's the frequencies that we cover with the Nautel RF Toolkit. Our RF Toolkit is licensed by Roger to operate between 40 and 108 megahertz, between 170 and 255, between 355 and 960, and 1.35 to 13 gigahertz. That's for the coverage map function. For the point-to-point links, however, it operates between 20 megahertz and 13 gigahertz without a problem. And Roger, we should probably mention that the radio mobile software that all this is based on covers all the frequencies. It's just much more complicated and configurable, much more capable, much more configurable than the RF toolkit that we have online.
Well, yeah, the main gain is that also with the online version like that is to have the platform independence. So you can run this Nautel coverage tool on an iPad as an example.
Sure, that's right. That's right. Okay, so continuing on. Can the RF toolkit help analyze advanced situations like directional antennas or other frequency bands or SFN interference? And really the bottom line is no. it's designed to be very simple to operate, and because it's simple to operate, it means that it's relatively sure that you're going to get the positive result that you want, an accurate result. So if you want to do things like directional antennas or other frequency bands or SFN interference zones, you can do them, but you got to use the radio mobile program, and it's very, very configurable, which is another word for complex, which is another version for complicated. Now, one advantage of that tool, and you can download that program for free from that website. However, there is a great online users group on Yahoo where users discuss the various ways radio mobile can be used, and you can log in and get that information there. You can join that users group, and the people who are on that users group would be happy to help you, I think, in understanding how to do some more complex things, like to enter in the pattern of a directional antenna, for instance. The number one question we always get from our customers is, how about AM? Is there an RF toolkit that can provide similar coverage maps for AM stations? The answer is, unfortunately, the RF toolkit only works in the broadcast allocations within the VHF and UHF bands. At this time, we don't have an answer for AM or medium wave frequencies. We continue to think about that. It's a whole different kettle of fish. You have to have ground conductivity in there. And probably the biggest thing that you have to consider is the existing atmospheric and noise environment, both intended and unintended radiators applying in that band. So not nearly as simple as calculating FM or TV coverage. Much more interesting. So now we get to the point where we get the chance to answer your questions. I am seeing here already some questions, and let me pull them up here. 1 second. Let's see here. Yeah. And I should be able to expand that out. Yep, okay, like this. All right. Raleigh from New Zealand says, greetings, I guess. So there's not much of a question. Second one, Gordon says, suppose I want to see coverage out to the 54 dBu contour. That's easy. So what you can do is you can set up the custom receive coverage, and then in the custom area, you can set up the 54 dBu contour, and that will work for you, Gordon. Paul says, any way to overload those details in Google Earth? And yes, I think we demonstrated that. So it works. What you have to do is to take and download the advanced files at the bottom of your coverage map, and then rename that zip file to KMZ. Rename the zip file to KMZ. Install Google Maps Pro on your machine, and then double-click that KMZ file, and it'll just work. And that's the way it's done. Please explain why the required reliability is 70%. Kamal asked that question. You want to go into a little bit more detail on that, Roger?
The 70 dB?
Yep. No, the 70%.
Okay. That's, as I said before, it's the prediction, okay, can be pessimistic or optimistic, depending on the percentage you select, okay?
Yep.
My opinion is that if you want to check the validity of your calculation, they should match the measurement in the field.
Right.
Okay? For that, you need to put 70%.
Okay.
If you want to have a very good link, you want more than that. We all agree on that, okay? The way to do that is to have supplemental margin.
Date margin, as we say, or gain in hand.
Put the calculation at 70% to have a realistic value of the measurable signal, and you verify your margin.
Right. Okay. I should also answer that a number of people over the years that have been using our tool have found that the coverage when they build the site is very much similar to what the Nautel tool has done. So I would say that this is pretty well proven. When we built the the community FM station up in Nova Scotia, near where Nautel is located. The work, the preparatory work of the analysis of the coverage was all done with the Nautel tool, and it proved to be spot on. It proved to be exactly right. Kurt answers, please, is it possible to enter the specific model of the transmitter in the simulation? No, but you can use custom setup, and you can use a particular transmit output power that you would choose. We just had some set values to make it easy. But you certainly can enter in the power output. We really don't care what the model is as much as the power output. Aziz from Dubai asks, could you explain what the group option in the new transmitter site menu does? Roger, over to you.
Can you put it on the screen so we see where it is?
No, it's what he's asking is, could you please explain what the group option in the new transmitter site menu does?
Our group is okay. It's like a second description you can have.
Mm-hmm.
And when you do your multiple coverage, you can have only those that are within a specific group to display.
Okay. Okay. Very good. Dane asks, I've used the toolkit, but this morning is the first time exporting to Google Earth. The result is a big red X over the covered area. Any thoughts?
Exporting to Google Earth?
Yeah.
We don't have that.
He says, well, I mean, if we use the advanced file and then change it to a KMZ and then click to it, he's getting a big red X over the covered area. Any ideas on what might be causing that?
He changed the zip name to KMZ?
I think he must have. Maybe not.
Probably a typo, or I don't know.
Okay. All right.
The picture is missing. If there is a it says the picture is missing.
Okay. It says, Francisco says, can you customize an antenna system like a directional pattern? That's not a function that's within our program, but you could use Radio Mobile, the links that I showed you, to get to that. So yes, you can do directional patterns, but not on our program itself. You can use Radio Mobile to accomplish that. What type of coaxial is used in the point-to-point link to calculate 0.66? So you need to know the approximate length of the feed line from the receiver to the antenna, and calculate out the losses for that particular type of feed line. That's pretty easy to calculate if you get the manufacturer's information on the feed line that you're planning on using. If you have two transmit antennas in one tower, will it affect the propagation pattern of your transmission? It could. Are you saying that both of those are driven, in which case that would be a directional antenna and we'd have to do that in Radio Mobile? Or are you saying that they may, one's stacked above the other one, for instance, and you're concerned there may be some interference? That's possible depending on how close they are. I would talk to the manufacturer of the antenna and see what their perspective is on that. And let's see, can I do a calculation for a point-to-point in the 5.8 gigahertz band for this tool? Point-to-point, yes, you can. Yes, indeed. Can you change the coverage plot colors? Green is often masked by the national park areas on maps. That's an interesting question. Roger, is it possible to customize the colors?
If we switch to OpenStreetMap, we will have the capability to have a gray background.
Okay.
That will resolve the issue, because what we want to have is a nice report where your work will be in color and the map doesn't have to be in color. So that's the best way to do it, I think.
Yep, I agree. That's a good idea, and I think the transition to OpenStreetMap will probably occur sooner rather than later. This is an interesting comment. Kevin says, just a comment. I want to thank Roger for this program. I've been using Radio Mobile online for years, doing coverage estimates for wildland fire communication systems. So consider yourself congratulated, Roger.
Oh, thank you very much.
Always nice to have somebody say something like that. There may be other questions. We will answer those after the webinar is done. Let me make sure we're looking at the right page here. We are. So, let me hit F5. So, for additional information, hopefully that's the screen you're seeing right now, Roger. There is a very valuable Radio World ebook at the URL shown in the upper left-hand corner that has a lot of questions and answers about propagation analysis. This was sponsored in part by Nautel, and we're very proud of it. You can get to the Nautel toolkit we've been talking about at this URL here on the right-hand side. My email address is down in the lower left corner, and you can take a look at the dozens of Nautel webinars that are available online, as this one will soon be recorded at the web address in the lower right-hand corner of the screen. So, Roger, any final thoughts that you'd like to offer to our friends here?
Yeah, for sure. We try to. The way we work on these tools is to help, but not to replace the official engineering work, okay? So sure. When I hear about possible antenna pattern and things like that, I consider that as a more professional work than just a what if. What if you don't, changing the antenna pattern will not resolve most of the issue due to the topography itself. Right. So that's why we have this tool. It's to save a lot of time and money to have a best guess, let's say.
That's a good point, Roger. I mean, the things that we just did in the last 45 minutes, when I got into this business some 40 years ago or more, in order to do a propagation analysis, and I did them back in those days, it required topographical maps covering desks, and you drew radial lines on there, and then you made marks and calculated the elevation at each mark, and you transferred all of that to graphs, so you had the side view of things, and then you calculated out with lots of slide rules the coverage of a station, and it took literally a week to do what we did multiples of much more accurately in the last 45 minutes. Did you have a similar experience, Roger?
Oh, yes. I began my career in 1972 at a government department, and we were doing propagation analysis all over the province of Quebec. And that's it. It's about a week. At that time, it took a week to calculate one site, the coverage for one site, and it was not very precise. I must say, it was less precise than what we have now in a few minutes.
Yes, yes, and it ends up with a much prettier presentation than we ever got when we drew on what was oftentimes maps gotten from gas stations.
And one thing that this new approach bring if you have holes in your coverage, okay, it was not something that was easy to show before. But now with those topographic tools that we use as a background, if there is a place where they don't receive the signal, you see it quite well.
That's right. That's right. Well, Roger, I want to thank you for being a part of this webinar, and thank you for your assistance in making the RF Toolkit possible for Nautel to offer to our friends and customers. And I want to thank all of our listeners for being a part of this webinar today. I think we've gotten nearly a record number of listeners today, and I know that when we put this online and let people watch it from the Nautel website in the future and recorded, it'll get an awful lot of value too. So I hope everybody has good luck in running the software. For now, that's the end of our time. I thank you all. For Roger Coudé and for Nautel, I'm Chuck Kelly, your host, thanking you for being a part of our webinar today. Bye-bye for now.